All right. Now, here's what I'm going to do. Even though most of you have gotten way past this, I want to go through all the steps because you don't actually, when you get to a result like what you've got and you're like scratching your head, okay, you've really got to make sure you haven't done anything wrong. And there are lots of places that things can go wrong, okay? For starters, let's double check this equation. Is this actually a legitimate equation? Or did I fool all of you? Is this the time? Is this the time? How would you know? You need to check the geometry, right? You need to make sure, okay, for instance, classic example of doing it wrong, okay, is that, for instance, you might get the Pythagoras wrong. Like, this might have been 16 minus x squared instead of 16 plus, okay? It's a common example.
But why is it 4 minus x?
What? Okay. Yeah, okay. I'm making sure that you check it, okay? That you don't just accept it because I told you, okay? Or you don't just accept it because you came up with it the first time you looked at the question, okay? Now, let's just double check it. I'm after this length here, right? That rowing distance, okay? 16 plus x squared, it is the hypotenuse. That's right. 4 is the rowing speed. 4 minus x is this distance, okay? Because we were trying to debate, should you pick this one as x or this one? You picked that one, so, okay? And 5 is the walking speed. So this equation checks out. That's fine. Haven't reached the problem yet. This domain restriction, where did we get that from again?
From Jesse.
We sort of got it from common sense. We said it wouldn't be, yeah, you would be giving yourself extra work if you rode to any point outside here or here. That's what values outside this domain would mean, right? Okay, so restriction's okay. Let's differentiate. Now, t is what I've got on the left-hand side instead of, like, say, y. Okay, so it's going to be dt on dx. Okay, now, here's another place that things go wrong. Did you differentiate correctly? Look at your steps. There's chain rule involved here. Okay, what's it gonna do? You gotta do the inside. Okay, so that's gonna be what? 2x. Okay, you gotta do the outside. So that's gonna be, the power's gonna come down, right? And then the power's gonna reduce by 1. So it's gonna become not a half but minus a half. So it goes onto the denominator. Right? Does that look right? Does that look okay so far? Or have I goofed something? Is that okay? See, here's the thing, right? In an exam, right, when you don't have someone telling you, yeah, these are the steps, okay, you've really got to know for sure. Have I done this? Have I differentiated correctly?
That's what we did.
Yeah.
You're happy? Okay, this is going to simplify in a second. What do I do over here? Okay, please don't do quotient rule. Okay, this is 4/5. 4/5 minus x on 5. 4/5 minus x on 5. Two fractions. The constant disappears. Minus x on 5 becomes minus a fifth. So far, so good?
Yeah.
On the top there, that half and that 2, you can get rid of those. So there's your derivative. Happy? Yeah? Okay. So now, you want to find some stationary points, right? So actually, you want to find turning points. So you solve for that derivative being 0. Yeah? Okay, now let's fast forward a little bit, okay, because I think everyone has gotten the same result. You let this equal to 0, so the 1/5 moves over, you cross multiply, you square out, okay? You're going to get x equals 16 on 3. Yes? But that's 5 1/3, which is outside the domain.
Wait, so can that still work?
Well, let's think about that. Let's pursue that.
Why don't we just
Okay?
graph that?
So okay, I'm going to get onto the graph in a sec. Actually, I think we can do this. You could graph it, but I think you can do it without a graph if you think. Okay. Now, this is 5 1/3. Okay, 5 1/3, which is outside the domain. Now, what does that correspond to? Okay, that would mean I'm rowing to some place over here, and then I'm backpedaling. Now, that can't possibly make sense, right? Because if I'm going that far and then walking, that's got to take longer than, at least, rowing directly, right? I'm not sure about the other stuff, okay? But surely, you know, between here and here, right, rowing directly should be faster, right? Right?
Wait, is it because you need an absolute value sign?
Okay, now, What's going on? Now, I'm trying to dig to the bottom and not just tell you, okay, it's wrong. It is wrong, okay? But why is it wrong? Okay, why is it wrong? The stationary points, right? You differentiate and find, okay, what's going on? Let's test some points and see what's happening. Because, you know, when you have issues with your stationary points, the other thing you got to look at are discontinuities, other stationary points, or boundary values, right? So let's check them out. What are the boundary values? I've got well-defined ones, 0 and 4. Okay, so draw yourself up a little table. X first, okay? What value of x and what time I get as a result, okay? So I'm going to test out my endpoints, 0, 4, and just for the sake of it, just to see what's going on, I'm going to test this stationary point I got, which is outside the domain. Now, what happens?
1.8, 1.4, 142, 135, and 1.42.
Okay. Sure enough, these are the values you get. By the way, you've got to get the actual values, okay? What's happening here? This is less than that. Why is that's the sound that happens inside my brain when I get a this doesn't make sense. Okay, that's actually what I hear.
Is it because walking is the negative time?
Aha. Okay, now I told you all, my clue was that this part of the equation was where it breaks down. Okay. Now we said this domain, we put it in place, we made it up on the basis that it shouldn't make sense, right? But there's another way that you can think about it. There's another way you can get this restriction. Namely that this time is one component of the journey plus another component of the journey. So that means that both of these things must be positive, right? There's no lengths you can put in here that can make these times negative, right? Right? These are times the quantity, okay? So therefore, this 4 minus x on 5, okay, it must be greater than or equal to 0, right? So, of course, you go 4 minus x, because you multiply through by 5, okay? And then you land on this same thing, okay? So this x is greater than or equal to 4 is not just because it makes sense. It's because, other way. Multiply by minus 1. It's because not only does it not make sense, but it actually breaks the equation. This equation only tells us the time provided you stay in the domain. Once you go outside this domain, okay, what happens? 4 minus 5 and a third. This time becomes negative, right? So suddenly, rowing further and walking further is sending you backwards in time. Now that's why this value is less than this one, okay?
Wait, what?
I'll say it again. When you go outside this domain, okay, this part of the equation, 4 minus x on 5, no longer tells you a time. It tells you a negative number, which is nonsensical. It's telling you that as you walk further in that direction, you take less time, right? You think about a number. Let's go, x is equal to 100, okay? This is going to be 4 minus 100 minus 96 on 5. So it's like, I arrived. I arrived 18 hours ago, okay? So this equation only tells you the time in this domain. Outside that domain, this is rubbish. Okay, this doesn't make sense. Okay? So therefore, what's the answer? Okay, the answer is, well, how would I actually say the answer? I would say the turning point. It is, by the way, a turning point. It's not just a stationary point. You test the. You could test the second derivative, but it makes more sense because it's on the denominator. You're gonna have to use quotient rule. Just test first derivative on either side. Okay, you'll see it's a turning point. But the turning point lies outside the domain. Okay. So this is actually what you write, by the way, in your answer, because you've got to account for this number and why you're going to ignore it in a second. Okay. Hence, the minimum must occur at an endpoint. Okay? That's why, right? That's why you get this value and you're like, okay, I've got to disregard it. Just like, actually this value here, you had to be careful because you had to say x is greater than 0 because you actually get two values for that. You get a negative when you take the square root, right? But in the same way, you're like, well, this answer doesn't make any more sense than the other answer, right? So then you come back to this, okay, you look at these two and you're like, well, this one's better, right? Therefore, he should row directly to the destination.
We're all right.
Trick question. Joke's all wrong.
Okay.
I'm not ready for that.
That's good.
Now,